Hello, geometry. I hope you are having a lovely Friday. I hope your quiz went pretty well. I know, especially fourth block, some of you maybe did not feel too prepared for it because you left class early yesterday. We will figure that out when I get back, but thank you for doing your best and taking your time here. Okay. Um, we're working on 1-3, distances and midpoint today. So, you had your worksheet yesterday. I left a note in the subplans to have you look up your answers on Schoology before you started your quiz, so I hope that you did that. Please make sure that that worksheet gets handed in at some point before you leave today. Um, if you didn't finish maybe the back page, like the last couple, that's okay. I want you to hand in what you had completed. So please make sure to hand that worksheet in before you leave. Okay. So 1-3, distances and midpoint. You're looking on page 5 right here. So we had already done some at the top of the page here yesterday. So we're working at 1-3, distances and midpoint. Okay. We're going to cover the distance formula and some of the midpoint formula today. It's probably going to seem pretty familiar because it is something that has been covered, maybe in middle school, maybe a little bit in Algebra 1. So I'm hoping to give you not that long of notes, and then you have some work time on Alex to complete your assignment. So it says the blank between blank. So what we're going to put there is the distance between 2 points is the absolute value of the difference between their coordinates when you're on a number line. So what it is essentially saying is you take one of your values minus the other value and you put it in absolute value bars. So element 1 minus element 2, and then it's in absolute value bars. So I've labeled, I have a number line here, and I labeled points A, B, C, D, E. It says the first one, find the distance between AC. It might also just say find like the length of AC, like that. So AC is going to be, we take our first element, like say A, that x1, and then we take our second element C. I take that second one that's at -1, subtract from the first one, which is -5. So again, this A right here, I'm counting as my second element, or sorry, my first element, x1, and then this over here, this x2, I'm making C my x2. So C was at -1, and I had A, which was at -5. So I've just substituted it into that equation thing, which is right here. So -1 minus -5, that simplifies. -1 plus 5, which would give us the absolute value of 4, which is just a distance of 4. Now, obviously, when you have something like a number line or a graph where it's a horizontal or vertical line, you can just count. Okay, if I'm going from A to C, 1, 2, 3, 4, I can clearly see that there are 4 units between them. That's totally fine as well. I just wanted to make sure that you understood that really what it is we're taking the absolute value between those 2 points. So if I look at C and E, C is at -1, E is at 5. So you're just going to take the absolute value of those two numbers, the difference between those two numbers. It doesn't really matter which one goes first, if I take -1 minus 5, or if I were to put 5 minus -1. Either way, -1 minus 5 gets us the absolute value of -6. The absolute value of a -6, that just means what is my distance from 0? That is going to be 6 units away. So we write a 6 right there. Okay. So that is just a one-dimensional distance. So either horizontal or vertical. So a straight line left and right or a straight line up and down. Okay, just kind of counting boxes. Then we get to the distance formula, and the distance formula is going to be used on the coordinate plane. So that's why it says coordinate plane right here. We're working with an x and a y value, not just one or the other. And so the distance formula is used when you're trying to find the distance between 2 points on a coordinate plane. Okay. So I just want to remind you that as you work later on your homework, I do have graph paper up on the front table in that drawer. And then I also have those whiteboards that have the grid on the back of them. So when you're working on your homework, if you feel like you need any graph paper, it's there. Okay, some of the stuff we do today works a lot better on a piece of graph paper or on a graph if you are a visual person especially. Okay, so keep that in mind as we go on. Okay, so bring me back here. Sorry, I'm all over the place. It says the distance, it's used in a coordinate plane. You have to have 2 points. We call those points x1, y1 and x2, y2. Then you can find the distance between the 2 points by using the formula that looks like this. It's a square root, and we can say y2 minus y1. We square that, and then we add it to the difference of the x2 and x1 squared. So it's basically saying, okay, find the difference in the y values, find the difference in the x values, square it, and then add them together. One thing to notice here, if you start with y2, you need to start with x2. If you have y1 right here, you need to have x1 right here. You will see the distance formula kind of switches based on where you look, because these two different parts, like this one and this one, they are interchangeable. They can go either the x's first or the y's first. It doesn't really matter. So sometimes they might get switched around. Don't be too concerned. Just stay consistent. If you do x1 first, do y1 first. If you do x2 first, do y1 first. So just be consistent. Okay. This formula here is going to be derived from something called the Pythagorean theorem. So Pythagorean theorem. Typically, most people kind of nod their heads like, oh yeah, I sort of remember that. A lot of people can spit out the a squared plus b squared equals c squared equation for it. But sometimes we forget kind of where it comes from or what it's referring to. So the Pythagorean theorem occurs when you have right triangles, or it's able to be used when you have a right triangle. So you have a right angle in the corner. The side across from that right angle is always your C, and then your A and B are just those other two sides. So it's saying if you take the length of A and square it, plus the length of B and square it, it is going to be set equal to the C value that is squared. Okay, so that's sort of what it is. A squared plus B squared equals C squared. And that is what derives that distance formula right here. Okay, so if you're a visual person, you might want to do Pythagorean theorem because it's easier to do that visually. Whereas if you are a very numerical person and you like a pattern, the distance formula as it's written over here can be very beneficial for you. Okay, so if you turn to the next page, okay, we have just a few examples here. The first one is going to have us go through both the distance formula and the Pythagorean theorem to find the distance between 2 points so that you can see how it works. Letters B and C, if I were there, I would just have you choose what method you like. Because I'm not there, I will write out both. You can kind of decide which method you like after we go through all of these and stick to that method or change it based on whatever numbers you're working with, okay? So on the back of the page, it says find the distance between point C, which is at -4, -6, and point D, which is at 5, -1. The first thing I always like to do is label these. So I'm going to call that C x1, y1. And I'm going to say point D is x2, y2. Okay. So x1, y1 and x2, y2 are my two ordered pairs that I'm going to use. If I'm going to write down my distance formula, and I can scroll back up here, y2 minus y1 squared plus x2 minus x1 squared. I write that out. I'm going to substitute those numbers in. So here's my y2 and my x2. That's going to be those ordered pairs there. And then I have my y1 and my x1, which is going to come from right here. So my y2, I see that it's yellow. I find my y2, it's a -1. I bring that negative down from the formula. Then I see that I need my y1. My y1 is a green, and it's the -6. Bring down the squared and the plus sign. x2 again is going to be that yellow one. It's the x value, so 5 minus x1, which is that green x value, -4. So I get 5 minus -4. I'm going to simplify it. So -1 minus -6. Really, you can think of that as a positive because two negatives make that a positive right there. So -1 plus 6, I'm going to get 5 squared. And then 5 minus -4, that's like a 5 plus 4, which is going to give me a 9 squared. Okay. So 5 squared is 25, 9 squared is 81. When I add those together, I get a 106. And in your calculator, if you take the square root of 106 and it simplifies, you get that it's about 10.3 units. Okay. So that's your distance formula. Again, the most confusing thing or the hardest thing is that it takes a while to kind of memorize that formula and get comfortable using it. Okay. Here's what Pythagorean theorem looks like. So for you visual people out there, this can sometimes be helpful. So if I'm just first start by graphing these ordered pairs, -4, -6, I go left 4, down 6 here, and I'm going to mark that as point C. Then point D is at 5, -1. So I'm going to graph that over here. So what it wants to find is what is that distance between those points? Okay, so to do that, I said you could use Pythagorean theorem. So if I go straight right from that C value and I go straight down from that D value, they meet at this point. This would be my right angle. Okay, so if I'm going to use Pythagorean theorem, here's my A, here's my B, and then this distance that we're looking for is our C. So again, we're saying A squared plus B squared equals C squared. Okay, well, I can look at this picture and I can just count the distance. So if I'm looking at how long is side A right there, it's 1, 2, 3, 4, 5. It's 5 units. If I look at B down here, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a length of 9. So there I have my A and my B values. I know that A is a length of 5, B is a length of 9, and that C squared, that's what we're ultimately going to be looking for because that's our distance. Okay. So I then take my multiplication. 5 squared is 25, 9 squared is 81. And again, they're the same thing, C squared, D squared. 25 plus 81, we end up with that same 106 equals C squared. And then we say, how do we get that C value by itself? Well, to get rid of a squared, you take the square root so that they cancel. And the square root of 106 is again that 10.3. So there's just the distance again. Okay, so I personally think Pythagorean theorem goes faster, but I'm a more visual person. It makes more sense to me than memorizing that long formula. Again, when it gets to work time, if you want to take out a whiteboard or if you want to go find some graph paper, it can be very beneficial to do it that way as well. So letter B and C. Again, it says to choose your favorite method. If you want to try to do it on your own, you can. I will still talk through it up here because so that everybody makes sure to get it down, but you do what you prefer. I'm going to start with the distance formula. So again, I'm saying the square root of y2 minus y1 squared plus x2 minus x1 squared, just like that. Okay. And if I call this x1, y1, x2, y2 from those two ordered pairs that were given, I'm going to substitute that in. So my y2 value is negative 7. The negative comes down. The y1 value is a 3, so I have negative 7 minus 3. My x2 value is negative 3. My x1 value is 4, and that's squared. Again, y2, x2 should be coming from the same ordered pair right there. Same thing with the y1, x1, is that they should be coming from the same ordered pair. Okay. So I keep simplifying. Negative 7 minus 3, that would give us a negative 10. Negative 3 minus 4 gives me a negative 7. And so I get, that my distance is the square root. Negative 10 squared is a positive 100. If you're putting that in your calculator, you want to make sure that that negative 10 is in parentheses before you square it. Same thing with that negative 7. Negative 7 squared, it's saying, what's negative 7 times negative 7? That's going to be a positive 49. So if I simplify that, the distance is 100 plus 49, the square root of 149. If you put that in your calculator, you're getting a 12.2. Okay, and in your calculator, if you're having trouble finding that button, you're just going to push the second button and then find wherever the key is that says x squared. Okay, so if you do second x squared, that's going to give you your square root on most calculators, if not all. Okay, let me just quick show you what Pythagorean theorem looks like. So again, 4, 3, that's my point J. Negative 3, negative 7, that's my point K. We're going to be looking for that distance. So if I go straight down from J, straight right from K, here's my right angle. I want to find the length of each side, A and B. So length A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And over here, B is 1, 2, 3, 4, 5, 6, 7. So if I'm going the Pythagorean theorem route, A squared plus B squared equals C squared or D squared, whatever you're using there. Remember, they're just talking about that side that's across from the right angle. That's what we're trying to find. I substitute those numbers in. So my A is 10, my B is 7, and the distance is what I'm looking for. Again, 10 squared is 100, 7 squared is 49. I get 149 equals D squared. To get rid of a squared, I take the square root, and so I end up with about a 12.2 is equal to D. And if you want to use approximately equal to, that's even better. Okay. Okay, so distance formula or Pythagorean theorem really does not matter which one you choose to do. Okay, as long as you can make it work. Okay, the last one then on this page. This time I'll start with Pythagorean theorem so that if you're preferring that, we can kind of get that done first, and then I'll do the distance formula. So I'm going to graph at -5, 6. I'm going to put that point E, and then at 8, -4, I'm going to put that point F. And so what I ultimately want is that distance there. So that's going to be my distance or my C value. I go straight up from F, straight right from E. I create that right triangle there, call these sides A and B, and find my distance. So if I start with side B, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's a length of 13 there. And then I look at A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I'm going to say A squared plus B squared equals C squared. My A was 10. 10 squared plus 13 squared equals that C or D squared. 10 squared is 100. 13 squared is 169. We add those together. We get 269 equals my distance squared. To get D by itself, we take the square root, and the square root of 269 comes out to be about 16.4. Okay, so the last part, we're going to do distance formula. So x1, y1, x2, y2. So again, if you prefer one or the other, that's okay. I'm just doing both up here so that if you are preferring one over the other, you can see both. So y2 minus y1 squared plus x2 minus x1 squared. I substitute my numbers in. So y2 is a -4, y1 is a 6, so I have -4 minus 6, plus, and then my x squared is 8, minus my x1, which is a -5. Keep going, -4 minus 6, that's a -10 squared. 8 minus -5, that would be like a 13 squared. Keep simplifying, -10 times -10, that would be 100. 13 squared is 169. So we get the square root of 269, which if you go and put that in your calculator, again comes out to about 16.4. We should be getting the same exact numbers with whichever method you choose. Okay. So we're almost done. We're just going to quick go through midpoint. So if you turn to page 7, which I know it seems pretty long, but there's not a lot of writing on here. There's just a lot of information. So the midpoint of a segment or the midpoint formula. We briefly maybe talked about midpoints yesterday when we were doing the segment addition. Remember when we had congruent segments that were in the same line segment, we were saying that they were congruent, which meant that the point that was separating them was a midpoint. Okay, so this is just bringing up what a midpoint is. The midpoint is the point halfway between the endpoints of a segment. So if we're looking at segment AB right there, if point M is the midpoint of AB, so that's your midpoint of the segment A to B right here, then we would say that the length of AM is equal to the length of MB. Okay, so this right here is congruent to this part right here, essentially is what that's saying. If you start on the left part of this little box here, if you want to find a midpoint on a number line, it's fairly easy because you're only working with one dimension. To find that midpoint, you're taking the x1 value plus the x2 value and dividing it by 2. It says x1 and x2. If it were a vertical line, it would work the same way. We would just call it x1 and x2 divided by 2. It's basically saying you only have one dimension to worry about. If you look at a number line, it is pretty easy to figure out where the midpoint would be just by like counting boxes. Okay, it's saying you have only one dimension you need to find the average of. Okay, finding the average of one variable. So this example right here, if we know that this is a number line, it's not completely marked, but we see that 2 is 1 point and 6 is 1 point. Those would be like your x1 and your x2 values, and we want to find our midpoint. We would say the midpoint is x1 plus x2 divided by 2. Where is it located? 2 plus 6 divided by 2. 6 plus 2 is 8. 8 divided by 2. It would tell us that our midpoint is located at 4. So right here would be a 4. Okay. Pretty simple when it's one dimension. So on a number line there. Gets slightly harder. I won't even say it's really slightly harder, but there's more to it when you look over on the right column and it says finding the midpoint in a coordinate plane. The midpoint formula for this, it involves two different dimensions. So we have to take the average of the x's and the average of the y's to get our midpoint right here. Okay, so it says if PQ has endpoints at x1, y1 and x2, y2 in the coordinate plane, the midpoint M could be found using that formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. You're finding the average of two variables. Okay, average just means well, add them up, divide it by the number of elements. So add up two numbers, divide it by 2. Okay, so I put a graph here just so that we could check our answer. Sometimes it helps to do this if you want to double check your answers. So if I'm using that midpoint formula, here's my x1, y1, x2, y2. So I'm taking x1 plus x2, dividing it by 2, y1 plus y2, dividing it by 2. So my x1 is a negative 6, my x2 is a 1, my y1 is 3, plus my y2, which is 0, divided by 2. If I simplify this, negative 6 plus 1 gives me a negative 5, so I have negative 5 divided by 2, and then I have 3 plus 0 is 3, 3 divided by 2. So my midpoint actually ends up being a negative 2.5 and a 1.5 if you like decimals better. So what I'm going to do is just graph these numbers real quick. So point S is at negative 6, 3. So here's S. And point T is at 1, 0. Oops, that's 1, 1. 1, 0 right here. If I connect those, it's saying that my midpoint is at negative 2.5, 1.5. So about this point right here is my midpoint. Just by looking at that picture, I hope that you're thinking, yeah, that makes sense. It does look like it falls right on that line. It makes sense for this problem. You would consider that you double checked it. It was great. Okay. Again, this is not a necessary step. Just wanted to show you that you can check your answer if you would like. Again, graph paper or the marker board is available. Okay, here's our last one. Example 2, find the coordinates of M, the midpoint of segment PT, for P, which is at negative 8, negative 2, and T, which is at 5, 1. Okay, so my midpoint, I add up the x's, negative 8 plus 5, and I divide it by 2. And then I add up the y's, and I divide it by 2. So negative 8 plus 5, I would get negative 3. Negative 2 plus 1, I'd get negative 1. And so again, negative 1.5, negative 0.5, if you actually want to go and solve that out. Okay, So I didn't put a graph there for you to see it, but that is correct. So the midpoint was at negative 1.5, negative 0.5. You can leave it as a fraction. That is totally fine as well. Okay. If you turn the page, you will see that there's some more midpoint stuff. We will cover that when I get back. So I just want you to focus on the plane distance formula and the plane midpoint formula, okay? So you guys can go on to Alex after this and work quietly on your assignment. You are welcome to have your music playing, but keep your cell phones in the pouch, okay? Have a great weekend, and I will see you guys on Monday. Bye.